Hello, everybody. This is another edition of Class in the Backyard. Okay, so earlier today I sent out a PDF form of the notes. So if you printed those off, your note taking might go a little quicker. But if not, just pause the video wherever you need to, and everybody wins. All right, so let's jump into it. This is 5.3. This is the first section on this long break that we've had where I've actually had to have a lesson, okay? You guys should have known the rules for exponents for the past 8 days worth of classes, right? Okay, but now we're going to learn some new stuff. The first thing that we're going to learn is exponential functions in the form of f of x equals a times b to the x. Okay, so there's a couple rules. Dang it. I'm trying to play ball with Mindy as I talk again, and it's not working out. There we go. There's a couple rules here. A and B must be greater than 0. Okay, so they can't be negative numbers, and they can't be 0 because that wouldn't make any sense if either one of them was 0. And B cannot equal 1. In other words, if I had 1 right here, well, 1 to any power, 1 to the million is still 1, and then that isn't growing exponentially, okay? A is just a multiplier. B, there we go. B is the number that's actually getting the power, to it, okay? So A is just out here, just hanging out. A can be, just a regular old number. Okay, so there are two types of exponential functions. You have growth and you have decay. Exponential growth and you have exponential decay. So when b, the value of b is bigger than 1, this is what growth looks like. When b is a fraction, so when it's between 0 and 1, then it's a decay value. Growth and decay. There we go. So a growth function might look like 3 times 2 to the x. A decay function might look like 3 times 1/2 to the x. All right, so let me show you what I'm talking about here. If I were to plug in numbers, let's say that I tried plugging in, I don't know, we'll do 1 and 5. 1 and 5, 1 and 4. So if I said, what's f of 1? You'd say, well, that's 3 times 2 to the first, which is 6. And if I said, oh, yeah, what's f to the... There's Mindy. Hang on. The ball had been sitting there a while. If I said, hey, what's f of 4? Then it would be 3 times 2 to the fourth, which is 3 times 2 times 2 times 2 is 8. Times 2 is 16, so that'd be 48, okay? And you can see as the value of f or of x increases, like from 1 to 4, these numbers grew exponentially. In other words, it grew pretty doggone fast, okay? So if I were to go back up to the graph, like right here, sorry, Mindy, if it was 1, then this number over here, like this dot right there, would have been 6, right? So that would have been 6 up. But then if I went over here to 4, well, then I'd have to go way up here and get, what did we say, 48? Okay. Give me the ball, Mindy. I can't reach it. All right, so now... Ooh, I'm using the ball thrower today too. If you guys have dogs that really like to play ball, I highly advise that you get Chuck It. No, I'm not getting paid for sponsors yet on my new YouTube channel, but I think that they could be one of the first companies that I could get money from sponsoring. Chuck It. Chuck It Dog Toys. I swear that's the name of the company. Okay, so now let's do another one where let's do the decrease. All right, but now I have to change the values of No, I don't have to change the values of x, but I had to change the value of b. Okay, so now it's a fraction. So let's say, and I'll do this one in red. Give me the no, she doesn't want to give me the ball. All right, so let's do f of 1 here and f of 4. Okay, so if it was 1, it'd be 3 times 1/2 to the first, which is 1.5. Go ahead, figure it out. It's 3 over 2, which is 1.5, right? Okay, now let's do to the fourth. So this would be 3 times 1/2 to the fourth. Well, that would be 3 over, what did we say 2 times 2 times 2 times 2 was? Oh, yeah, 16. It'd be 3/16, which is something like 0.2, maybe? 0.19? Gonna have to check that out. I'm gonna guess 0.19. Okay, so if I were to graph that, 1.5 and here's what it would look like. So if x was 1, then this dot right here would be at 1.5 up. Okay, but then if x is 4, dang it, I didn't change the color. Oh well. Then this value would be, what did we say, 0.12? Or no, 0.19. Okay, and so that's growing exponentially over here, and this is decreasing exponentially there. All right, moving on. Okay, so to find an equation from a specific point, do the following. Remember that f of x equals a times b to the x is our exponential function. So let's do an example problem. It would say something like this. Suppose 2 points on an exponential function were 0, 3, and 1, 2. What that technically means is f of 0 equals 3 and f of 2 equals 12. Okay, in other words, when you plug in 0, you get 3. And when you plug in 2, you get 12. That's what those ordered pairs mean anyway, okay? Got that? And remember, you can pause this video at any time. All right, this is a pretty easy problem, but very typical since one of the x values is 0, okay? So you could do this for anything. Your starting point would be times 0. Okay, so that's why I said it's very typical, is because your starting point when you did your experiment or when you did your observation, the first time, that time is 0. Okay, so that's why I picked one with 0. So here's our function. A times b to the x, but this time I'm going to write it as equals f of x, okay? Oh no, I moved the f of x on the other side. Big deal. Okay, so let's plug in f of 0 equals 3. That means when x is 0, the answer is 3. Well, b to the 0 is 1. So the value of a, the multiplier, is 3. Okay, so far so good. Sweet. Now let's solve for b. So now remember a times b to the x equals f of x because it's right over there. Well, now I'm going to write 3 times b to the x equals f of x. And now I see that I really want to move this part over here. There we go. And I'm going to put a line like right here so that you don't get too confused. Mindy's pretty tired because I'm throwing the ball with the chuck it. All the chuck it is it just makes the ball go further and faster. And so Mindy's running the whole length of the yard now instead of just a little part of it. Okay, hey, so now this time, what was the other points? F of 2 equals 12. Yeah, f of 2 equals 12. So that means when I plug in 2, I get 12. So now the 3 is still 3, b is still b, x this time is 2, and the answer when I plug in 2 is 12. Oh, I bet you I can solve for b. Sure can. Divide by 3 and do the square root. Okay, and remember b can't be negative, so it can't be plus or minus 2. It just has to be 2. So far, so good? So then that means, let's see. Do I have anything? Nope. That means I have to scroll now. Sorry. Okay, so that means that my function for this, my exponential function for this is 3 times 2 to the x. Okay, that's my function. A is 3, b is 2, and x is just x because I can plug in anything. So let's just try it just for the heck of it. Let's try what is f of negative 2. Okay, so if I wanted f of negative 2, wait, Mindy, I can't reach that. I can't reach that. Maybe I can with the chuck it. Hey kids, do you want to have hours of fun? Get the chuck it. All right, so if I plug it in negative 2, that would be 3 times 2 to the negative 2, which would be 3 over 4, which is 0.75. Now, if you want to see this graphically, which I did, I wanted to see if I had this right. Let's go ahead and graph this puppy. Extend that page. There we go. And let's graph this. I think I just have to go up to 12, right? Yeah, up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And when I went over to 2, the answer was 12. And when I was at 0, the answer was 3. And then when I was at negative 2, the value was small. I got to change color of dots here, don't I? The value was like right there. Okay? And then so this guy is exponentially growing like this. And you've seen a lot of stuff on the news about exponential growth lately, and it's not about money. So you could actually apply this to what's going on in the world right now. But yes, this is an exponential curve. This one's rather steep, okay? It's growing exponentially pretty doggone fast. Okay? So there you are, and there you have it with that one. Yeah, that's it right there. Okay, so we had these two starting points, and then we did this graph right there. And everything looks just peachy. Remember, you can pause this. Mindy, I cannot reach that. She literally puts it places where I can't reach it, and she knows it. And then she sits there. She sits and just looks at it. Like she'll just totally look there. I threw it that time. All right, so that one worked out. Graphically, it looks good. I don't think you're going to have to graph anything, but just wanted to show it to you, okay? Next. So now we have two forms, okay? We had an old form, which was pretty easy. Hey, the cost of a Ford truck, no, this one with a plus sign would be of a Chevy truck was $20,000. How much did it appreciate after 5 years because the value of Chevy trucks goes up? And so this was the old form that we talked about, and everybody was happy with that. The new form that we just learned was exponential function, which is a times b to the t, okay? T is time. And it's represented in just a function because it can represent a whole bunch of different things. And then the newest form that I want to talk about now is another a of t, and it does the starting amount, and then it's times b to the t over k. That's right, t over k. And new word, I promise this is a word, where k is the doubling time. Okay, so you're not going to understand this until I do an example about it. I think you'll be just fine with it afterwards, okay? So it's just new. It doesn't mean it's scary. It doesn't mean that it's super difficult. Just stick with me, and I think you're going to get this. We have a bird feeder in the back, and there are a lot of little birds that are very greedy. They're just like, oh, let me eat something. Oh, let me eat some. And then every once in a while, a big bird will show up on the feeder, and all the little birds will just go scatter away. But they're just eating away right now. They're just like, oh, I'm just going to go ahead and eat now. Okay, ready? Here we go. Let's say a bank promises to double your money in 8 years. What percentage rate is the bank promising? Okay, so it sounds pretty good. Oh, yeah. Take my investments and I will have twice as much, double, in 8 years without doing anything. What is the bank doing there? Okay, so let's figure out the percentage rate. This is pretty doggone easy. All right, it doesn't say how much money we're starting with. So, like, we could start with $10,000, or we could start with Brooks's Life Savings, so $2. It doesn't matter, okay? So, no, Brooks's Life Saving would be $3. Okay, but let's do this problem and see what goes on. I don't even care what the starting amount is. So, the amount of the money at a certain amount of time is going to equal the amount of money, and again, that doesn't matter because that's not going to tell me the percentage rate. Oops, I marked on my paper as I was throwing the ball to Mindy. And then I'm going to multiply that times 2 to the t over 8 because it said it could double it in 8 years, okay? So now I'm going to split up the power. Okay, in other words, t over 8 kind of scares me. All right, so I'm going to split it up. So it's going to be the initial amount. Again, it doesn't matter. It's going to be 2 to the 1/8 to the t. I split up the power because it's still t over 8. Then I got out my cell phone again, and I did this problem on my cell phone. I was pretty happy about this. And that's going to be the initial amount. And then when I did 2 to the 1/8 on my cell phone, I got 1.09 to the t. And so then that is 1 plus 0.09 to the t. So what percent is the bank promising? The bank is promising, whoa, the bank is promising 9%. Okay? And so they didn't want to say that they're promising 9% because some people could look online and say, hey, what is a good return rate for mutual funds right now? And if you did that, like I did, a 5-year average return nowadays is about 14%. Okay? I know this one was 8 years, so 14% is the average from big-time bank companies, and this bank was offering you, they just didn't want to say it, but they were offering you 9%. So they're going to keep roughly 5% of that. Okay? So that's a good thing to know. Here, let me go back. Let me go to split screen. There we go. Hey, did you notice? We took the newest form and we turned it into the oldest form. How about that? Look at that. Would you looky there? Okay. So we took the newest form by splitting up the power, and then we, and then we turned it into the oldest form. How How about that? Something that we recognize as our friend. And Mindy is back. Okay, we're almost done, I think. It's a little windy outside, and the papers that I had prepared are just kind of blowing around. But there's no lawnmowers today, and no really, like Mindy's not even barking. Ooh, I just threw it and it hit her on the head. With the chuck it. Okay. All right, this leads us to the rule of 72, which states that when something is doubling, you can figure out the time or rate by doing 72 divided by 2. No, that's wrong. 72 divided by 2. What? No, no. 72 divided by x. What the heck? Okay, so you know our last problem? I could have just taken 72 divided by 8 years and got 9%. Wow. How about that? I know. Here's the thing, you didn't know it, but when I was doing this problem, I already knew what the answer was, but I had to show you both ways, okay? But that only works on doubling, okay? Not tripling or anything like that. Okay, next. Now for half-life, and I think this is our last, yes, this is our last example, thank goodness. How long is our video? 21 minutes, okay? And so here goes, everybody. If something has a half-life of 6 days, that means in 6 days, half of it's going to be gone, okay? What's its decrease rate? What is it decreasing at a rate of, okay? And so it doesn't matter what the starting amount is, but we could put in something, but we're not going to. So the initial amount doesn't matter because I'm just trying to figure out the percentage. Instead of 2 for doubling, now I'm just going to put in a half. But it's still going to be t over, but this time it's 6 instead of 8, and you can't do a shortcut for this one. Sorry. Okay, so let's do this. You ready? Sorry. It's really dry out here. Okay, so again, I'm going to split this up. To the t, and then I'm going to figure that out in my calculator on my cell phone, and I got 0.89 to the t. And you're like, how am I going to write that as one of the oldest form? Well, let me show you. That would be a decrease. Hello. Of 11%. Because what is 1 minus 0.11? Oh, it's 0.89. Oh, okay, so all I did to get that 11% was just do 1 minus 0.89, and I got 0.11. So the decrease rate is 11% decrease rate. I told you it was easy once you saw it. There you are, and there you have it. Okay, so now here's the thing. I know that was a lot to take in. I'm going to give you the assignment. Mindy's back. And so is the chuck it. There we go. I'm going to write down the assignment on the next slide. There it is, 1 through 9. But on Monday, again, I'll post the solutions to them. And then we have to start thinking about how we're going to turn in all of our work stuff, right? Okay, so there'll be more information. I think Mr. Shipley's going to send out another email at some point explaining what the next step is. Okay, so live from my backyard, I say to you, good day.